Welcome to Ask and Learn.
All right, guys, we're doing problem 52, chapter 18 in Chemistry Central Science. In the lime soda process, once used in large-scale municipal water softening, calcium hydroxide prepared from lime and sodium carbonate are added to precipitate Ca2+ as calcium carbonate and Mg2+ as magnesium hydroxide. You can see those reactions here. How many moles of calcium hydroxide and sodium carbonate should be added to soften, or rather remove, calcium and magnesium when you have 1200 liters of water in which calcium concentration is 5.0 times 10 to the negative fourth molar and magnesium concentration is 7.0 times 10 to the negative fourth molar. So let's rewrite these equations. We can rewrite these as calcium 2 plus Na2 CO3 yields calcium carbonate plus 2Na. And magnesium 2 plus CaOH is going to yield Mg2OH. You can think of OH2 as effectively just a giant polyatomic ion that gets exchanged with your calcium. It's technically not true, but conceptually true. So you can see that there's a 1-to-1 ratio between the calcium and the sodium carbonate, and the magnesium and the calcium hydroxide. So let's start with calcium hydroxide. Let's start calcium hydroxide and magnesium. So since they're in a 1-to-1 ratio, the concentration of our calcium should be equal to the concentration of our calcium. The concentration of magnesium should be equal to the concentration of our calcium, theoretically. So now we're going to convert this to moles. So 7.0 times 10 to the negative 4 molar times 1200 liters equals 0.84 moles of calcium hydroxide. Now, conversely, the concentration of calcium should equal a concentration of your carbonate. However, we have an added complication that we don't just have the calcium that's in solution, we also have the calcium that we're adding in order to get rid of our magnesium. So that calcium is still going to be free in solution. So we're actually going to add the concentration of calcium, the 5.0 times 10 to the negative 4, and we're going to add that to the concentration of our calcium hydroxide. So we're going to have 1.2 times 10 to the negative 4 molar. 10 to the negative third molar. Times 1200. So we have to add 1.44 moles of our Na2CO3. And remember what I said, we have to add extra Na2CO3 because not only are we removing the calcium that's already in our container, we also have to remove the calcium that we add when we add calcium hydroxide into our sample. If we're not doing that, then it doesn't really mean anything. So the way to figure out this question is to understand the specific molar ratios. You have to understand have a good handle on the equations and the engines. You have to have a good handle on stoichiometry. Once you understand that, you can understand how to do this problem no sweat.